Good day, fellow. Setso is back. Today I just want us to consider this topic of analytical geometry. You see, analytical geometry. The first concept that we are going to consider is gradient. Gradient or slope. Normally we say gradient. Then now you just need to know that the formula of gradient is given by m is equals to y2, y1, x2, x1, like this. Suppose now if I have a line like this with coordinates of a being 1:2 and b, which is, let's say, 2:3, then I decide to ask you the question now to say, let us find gradient. Find gradient of AB. How then will you go about determining the gradient of AB? So simple. We consider the formula. We write AB somewhere here. Where you see 2, you can write B or A if you want to. Then A like this. X, we started with B minus X A. Then y of B, we have 3 like this, minus for A we have 2, x of B, sorry, we have 2, minus x of A, we have 1. Then let us subtract this minus this, we get 1, 2 minus 1, still get 1. Finally, we are going to get 1, sorry, which is our final answer, like this. Suppose if I were to further say to you, find now the formula, or let me say find equation. Let me ask you this question: equation of A B. How would you go about finding the equation of this line? We know that we have this general formula for the straight line, which is given by mx plus c. We have 2 of them. Some I know they will use this one. I'm going to explain both of them. But firstly, let us consider this one. Then we do have the gradient, which is 1, x plus c. We have y, you see. Then when you arrive at this stage, you can then go and identify one point that you will substitute. The point that we're going to take is this one, where our x is going to be 1, our y is going to be 2. Like this, our x1 plus c. Then we have 1 multiplied by 1, we get 1. C, if we say 2 minus 1, like this, we take 1 to the left hand side, we are going to get c, which is 1. You see? Then now we can then go and substitute this value to this equation. Then now it's going to look like this, plus 1. You see? Then now I want to highlight something, especially when using this equation, that our coordinates of A, we are going to substitute them where we see y1 and x1. See? Then for y, we have 2. Our gradient is 1. Then on x1, we take that 1 like this. Then let us solve. We have minus 2 1 multiplied by x is 1x. 1 multiplied by -1, get -1. Then let us substitute 2 to the right hand side. We're going to get +2. Finally, this is what now we have. You see, we have the same equation. You can use either this one or this one. Doesn't matter. Any of your choice. Do you understand? Now, let me highlight this, especially under the concept of gradient, that if your gradient is greater than 0, somehow, let's say if it is positive, you see, then your line has to be like this. You see, then if now your gradient is negative, your line has to be like this. Then now what is going to happen if our line is it's 0 now? So if our gradient is 0, our line is going to be like this. Do you understand? Then our gradient we get undefined if our line is like this. Do you understand? I just wanted to highlight this. Let me continue. Now, let's say we have this one now. Let's say if we have this situation now. Let's say if somewhere here we have a, which let's say it's let me say 1 is to -1 like this. Say somewhere there, if let's say we have b, which is 2. Let me just say 2, then 3. Somewhere there we have an angle like this. You see? Then now I decide to ask you this question to say now, find theta. Let me add alpha as well. How would you answer this question? Now, you see, then I just want to highlight something, that we have another equation of calculating the gradient, which is given by let me see, let me just write it like this. You see, you can either write it like this, or some they like to write it like this: tan theta is equals to m. You see, doesn't matter. You see, then we need this angle, which is theta in this case. Somehow we need to use this equation, but firstly we have to determine what the gradient. Let's go and determine the gradient. And a b, which let me say b minus y a, x b minus x a, like this. Then we have 3 minus, you see we have -1 minus 1 like this. Then for x we have 2 minus 1. This side we are going to get 3 plus 1. We have something like this. Negative with negative, we get a positive, which is 4 over 1. Finally, our answer is going to be 4. Then the gradient of AB, we get 4. Now we can then say tan theta is equals to m, which is our gradient of AB in this case. You see, let us substitute 4. Then we have tan theta. Then I don't have my Casio with me. I have this one. Going to say shift tan of 4. Then I get, let us round our answer to 2 decimal place. I get 75,96 degrees, like this. You see, now we know this value. We can then now determine this one, the other one. Then we can just say alpha plus theta is equals to 180 degrees. Y angles on straight line. This one we already have 75,96 degrees, 180. Then theta is going to be 180 minus, we take this one to the right hand side, 96 degrees, which is going to be now 180, 75,96. I get 10,04 degrees for alpha. You see, like this, we have managed now to determine the equation of, the angle of alpha and theta as well. You see, then let us continue. Let us continue. Now, the concept that I want to highlight is this one. If we have two parallel lines, let's say, say if we have AB somewhere here, let's say we have A, B, C, D. For the parallel lines, you just need to know their gradient will always be equal. Gradient of AB is going to be equal to that of CD. You just need to know this. See, then now for perpendicular lines. See, let's say if we have something like this, say we have A, B, C, D. Then now, as for perpendicular lines, the gradient of AB multiplied by gradient of CD must give us -1. You see? Then, let me give you one example now. I want us to use these two, especially this one. Let us consider this diagram. Suppose if, let's say, I have a situation like this now. Let's say if this one is our diagram A, B, C, D. Given that these two lines, they are perpendicular, Then they also give us the coordinates of C, which is, let's say, 1 is to 2. Say they give us this one to be 2 is to 3, like this. Then now suppose they ask us now a question to say find the gradient of let's say AB. How would you go about determining the gradient of AB? Firstly, we need to determine the gradient of CD. Go to this equation, CD yd minus yc, xd minus xc, then yd is 3 minus, for c we have 2, we have 2 for this one, we have 1 minus 1. This one is going to be simple. Then 3 minus 2, we get 1. We also get 1. Finally, our gradient is going to be 1, like this for CD. Then in order for us to find the gradient of AB, we'll then say gradient of AB multiplied by gradient of CD must give us -1. But now we know of this one, it's of CD, we know of CD, which is 1. This one is -1. If we divide by -1, we're still gonna get -1 this side. Then now the gradient of AB is going to be -1. You see? Then let me try to change this thing. I want us to get a fraction. You see, you must know on how to work with a fraction. You see, let's say if we had, let us consider something like this. See, I won't change much here. I only changed that number. You see, we will still say D is 3 minus C, which is 2. This side for XD, we have 4 minus, let me see, it's 4 minus 1, like this. We get 1, this side we get 3. Then now, this is our gradient for CD. We need now the gradient of AB. Consider this, because these two lines, they are perpendicular. CD minus 1. Then the gradient of AB we have, we want of AB, CD we have 1/3, like this, -1. Then in order for us to solve for this one, it depends on individual. You see, one learner will say, okay, let me multiply by the reciprocal of this, then it's going to be 3/1. Even this side, 3/1. This cancels this, it's like this cancels this. Then I have AB, this side, then this side you are going to get -3, which is now the gradient of A and B. Do you understand? Like this. Then let's say now I decide to ask you this question to say find the equation now, the equation of AB, how would you go about determining the equation of AB? You pick as well which one. Let us pick this formula. Let me use this one because I know most like to use this one. Then now we have the gradient, which is minus 3x plus c, like this. Now they want us to determine the gradient of AB. AB, we are not going to use this coordinate. Instead, we need the coordinate that correspond with this line. In this case, it's going to be C. Then we have X and Y. Our X is, sorry, our Y is 2 minus 3x is 1 plus C. We have 2 minus 3 plus C. Take this one to the left hand side, it's going to be plus 3C. Our C is going to be 5. Then you can then take this and substitute it here. We're going to get something like this now. 5. This is going to be our final answer. You see? I hope you do follow. I hope you do follow.